Hello, everybody. Welcome to the weekly AI Revolution call. I'm Bryce Smith here with John D. Oliveira, and I work for Cody Willard at Trading with Cody and the 10,000 Days Hedge Fund, and we are here as always to talk about AI, baby. So
Yeah, I don't know. It didn't seem like as big a week, maybe in terms of
I was thinking that. Had the same thought.
in terms of news making. I know one thing that the CEO of Stability AI was fired by the board. So they're known for being the powerhouse among open source. They're putting out they put like like the Dolly type thing, except for them it was what is called SDXL, or they had the Stability kind of image creation, image generation kind of thing that was really good. That's the next version that's going to come out is as well. And I don't know the guy's name as Emad Mustak. He's been around and everything, and I'm not sure what he did wrong, but it's the word on the street. Nobody's very surprised that.
Is he going to get going to go to work for Microsoft and then maybe get rehired back by the board, and then the whole board's going to leave? Is that what you're
That's expecting? A big one that happened that maybe we didn't talk about was that the Inflection, the other AI company that some people for a while thought was just going and using somebody else's model, but I think they were doing their own stuff. But is his name Suleiman? The guy, he was one of the founders of DeepMind that Google bought back in the day for $4 billion. I think this DeepMind is the ones that taught a computer to beat humans at Go, which is much harder than chess. And it happened maybe 10 or 20 years sooner than they thought it would happen. So DeepMind were the real gorillas on the block for like powerful AI before OpenAI came along. So anyway, two founders, one of them ended up at Google, which is where DeepMind was, and the other one is now running AI for Microsoft.
Oh, wow.
He was the CEO of at Inflection, and now he's the CEO of AI, or CEO of.
So, John, what does the CEO of AI at Microsoft do? Because I thought Microsoft was using OpenAI.
Microsoft's using a lot of things. Microsoft made a deal with Mistral as well, the French company that makes the best open source AI. They're getting their hands in everything. They're not they don't want to get left behind. They're doing it both partnerships, and they're doing it by having those places use Azure and by them building services on top of the stuff. But they're also looking to be the ones who come out with AGI. They want to be the ones.
Well, yeah, it's weird. Speaking of that, John, so Microsoft, this is an old Microsoft computer that I'm using right now, and they do these over-the-air software updates, and they, probably a month ago pushed out Copilot to me, which is, as far as I can tell, it includes ChatGPT-4 right here on the sidebar for free, and I didn't pay anything for that. I didn't really even ask for it, but it's there. And, we pay for ChatGPT subscription, and you would think OpenAI might be kind of pissed about that. Hey, you're giving away a ChatGPT based product for free, unless Microsoft is compensating them on the back end.
They got $20 billion from Microsoft. So I mean, if $20 billion as an investment isn't going to, calm you down and keep you quiet, I don't know what is. It's like they can't complain later on. Oh, it should have been 40 billion. Microsoft made the deal early on. So,
do you think this Microsoft's approach to kind of doing this shotgun style and investing in all of these different companies and outsourcing most of it, but maybe they're insourcing some of it, is that a viable path to AGI? And I know that's kind of an abstract concept to begin with, but
yeah, it is.
I mean, that's starkly different than what Facebook or Meta and Tesla and others are doing.
Everybody's got their own approach. For Microsoft's approach, I go like this. I'd say, wow, that sounds like it'd be a great thing to do as long as you didn't, piss everybody off so much that you couldn't actually, maintain the partnerships and everything. Well, but they can. So if they can maintain the partnerships that they're doing and they kind of have a balancing act there, then why wouldn't they, do what they're doing? And then the biggest thing, we talked about it at one point, and this is where my mea culpa comes up this week, is, that the biggest thing that all these places need is compute power. And I pushed back and said, it's a mixture of things. There's that. And then there's the, things like the transformer model. Here's the thing that since that we talked is that found out somewhere that, the transformer came out in what, 2017?
Yeah, 2016, 2017. Yeah, I think that's right.
And this isn't like just for, people like, so this isn't like the movie, The Transformers. And this isn't like a transformer, like some electrical device or something. This is the architecture that all of this modern stuff happening with AI today is based on. So everything you hear about language models, it's based on this transformer encoder decoder structure, which is pretty complicated. And I've studied it in some depth and have never, made anything with it directly myself. But that's the thing that was like an innovation. Like, look, now they got this transformer. Now all this stuff will happen. So what I just found out was the earliest paper on transformer related stuff was in the 90s, in the 1990s. That's how far ago. So really the notion that what made the difference was compute power, it, holds up even more.
I see.
So everything you guys said was right, and everything I said was wrong, and et cetera, et cetera.
Well, and yeah, I mean, to be clear too, it wasn't really me, but I cribbed the idea because I saw an email from Ilya Sutskever, I think was who it was, when all this Elon Musk stuff was going down, and they were saying, hey, our algos haven't really changed in 15 years, 20 years, but we have a lot better computers than we used to have. So that's where that idea came from. But what's is also interesting on that, John, is I think Elon Musk tweeted this week and said Tesla is no longer compute constrained for its AI stuff. So meaning it's either got enough NVIDIA chips on hand to do what it wants, or its Dojo custom made chip is doing what it wants. I mean,
yeah.
But Elon Musk said that, I think, since we last spoke.
So like that gets at what I was actually where I was going to head, which was with the Microsoft, which that Elon Musk statement is just another example of it. Is all of these companies and projects kind of posturing for the sake of getting the best talent. So other than compute, it's talent. So they're all trying to make sure they get the chips, but that's something anybody can get. There's no moat around, going and buying a bunch of chips, because the next guy can go buy a bunch of chips as well.
Except that they cost $40,000 a piece.
$40,000 for one, like, in your think of your computer, and it's got the CPU in it, and the CPU probably costs $500 toward the overall, cost of your machine. So take that and multiply it by 100. 500 becomes 50,000. So I mean, it's like, $40,000 for just the CPU of the Blackwell, the new chip there. So yes, compute, expensive as anything, hugely important for getting this stuff done. Then you need PhDs. Mm-hmm. And they need to be very hands-on PhDs. They need to be the guys who can get in there and who do like linear algebra, matrix math, like in their head, and understand the layers and layers of architecture and how the changes take place in things, can go and take a research paper somebody else did and turn it into something, that works within their own org within like a week. Like, oh, I get what they're after. Let's try to do it this way, that kind of thing. And these folks are in super high demand, and there's super few of them. And they are being tugged like olive oil substance, the cartoon character, in every direction. By OpenAI, Microsoft, Tesla, Meta. Who else? I mean, that's like they're really hard to get. And where are they going to go? They're going to go where they feel like there's a chance at success. And so these places have to. That's why a month ago, Mark Zuckerberg's like, our number one goal is to achieve AGI.
Right.
For your whole company, that's your goal. Wow.
Right.
They're also, why would they say such a thing? Because if they don't say it, they don't get the talent.
Mm. Yeah, and Elon Musk said something very similar as well.
Yeah.
So, for context, John, I have no idea, but what is a mid-level AI computer scientist, engineer? What kind of compensation are they looking at if they're going to go work? If they're worth their salt and they're going to go to Microsoft or Meta or Tesla, what are they bringing home a year?
For the top ones we were talking about, like top, not the very top person, but like in the top tier, I've heard of numbers like anywhere from 750,000 a year salary to 2 million a year salary.
Big bucks.
So like Karpathy just left OpenAI. He's one of their top people, Andrej Karpathy. So
he left.
Yeah, well,
I did not know that.
He announced he was leaving, so I think he's gone. If not, he's
wow.
He'll be out very soon.
Well, I didn't even know that he had made the announcement.
Didn't announce where he's going next. He came from Tesla. He could end up back at Tesla. That's what some people think will happen. But what people were like, well, what could he command? It's like, I don't know, 40 million. He's considered one of the, he fits on one hand with the top 5 in the world. And these places are throwing around billions of dollars, and like, so a person who's we're not even talking equity. We're talking like how much money could he get per year if he wanted. It's like ridiculous.
Wow. Yeah. So it does say here, hi everyone. Yes, I left OpenAI yesterday. Okay. February 15th.
Okay.
Wow. Yeah, no, I know who he is. I know he's a big deal because of all the work we do on Tesla all the time. And Karpathy was a big part of Tesla for many years and then left. And then that's also part of this big spite with Elon because Elon founded OpenAI and then he loses one of his top AI guys at Tesla to go to OpenAI after they've had their breakup, So more drama there with it's got to be a small world, right? Like I am not in the AI world in the technological side. And it seems like there's really a handful of people that are at that level that can really actually go out and build these kind of amazing products.
I think I've been wrong before, so who knows, but I have my doubts about whether there maybe there's too much of this kind of hero worship of the top 5,
really,
where the people that work with them are, probably you could go down into the top 200 and they're still like ridiculously genius,
talented people.
So whether some of them work their way into a position where they're influential about how decisions get made, but it's hard to say.
John, from your perspective, what's the most difficult, mentally challenging part of the AI stuff? I mean, is it like you were talking about understanding transformers and the kind of that root, fundamental enabling technology? Is it LLMs? Is it the silicon side, what NVIDIA is doing? I mean, you're a smart guy and you've studied this and been in this forever. What do you think is the most challenging?
Well, you threw hardware into it as well, and that makes it really broad. And I gotta remind of the what's the book where the guy says no one can make a pencil? You know that one?
Yeah. It talks about all the people like from the lead and wood to the saw to cut the wood, that whole thing.
So like if no one can make a pencil, which I believe, I agree with that argument, then certainly no one can make a computer.
Mm-hmm.
And, so like when you narrow it down like that and you go, oh, is it this aspect or whatever? There are like mega geniuses who deal with this one aspect of the, the hardware and
Yeah.
how it's structured. And then there's others who deal with this piece and that piece and so forth. And there's no one who can do it all. So I go just into the software side of it, and they're building these models. To me, when I can only go from my experience of
Sure.
what I've tried to do, and I find the math to be really hard. When you try to piece together what this machine is doing to manipulate matrices, tensors, a tensor is like think of a Rubik's Cube. It's a 3D matrix.
Okay.
Rows and columns in multiple dimensions and directions, right? So that stuff is what's getting like added together and something else happening to it. And your model that goes and trains on all of the internet is like this giant machine. It's like, have you ever seen DNA? If you've ever seen like DNA happening, splitting apart and all the stuff going on, it's super complex. That's like this stuff stepping through its different levels of, and then bring this piece in and then do that and so forth. And if they've got to get in there and go, we want to do it a little differently to see if this happens or that happens, then they've got to really understand all the inner workings of all of that. And it's super complex.
Yeah. I do think, and I agree. From what I've seen, the little bit I've tried to study it is, these huge tables of almost like what I would describe as like decision trees kind of things that get just massive, and with inputs and outputs. And that's why they call it a neural network, right? Is that's somewhat what we think of how the human brain actually works, is kind of all of these thousands and millions of different decision things, neurons working together to come up with a reasoned decision based on.
Yeah, I mean, we end up using whatever. We make analogies based on what we already have understanding of.
Right.
The brain used to be described as being like a steam engine because the steam engine was the most complex thing people knew.
Mm-hmm.
So whenever we get more, now people might describe the brain as an operating system, the brain as a computer, because it's the most complex thing we have. And so it's what we use to go compare against. So I don't know, I wouldn't use a decision tree, but I would talk about the brain and
yeah,
the neurons and stuff. You've got like the idea of a signal that gets to a next neuron, and it has to determine whether it's going to fire or not, whether it's going to cause the stuff that it's connected to have stuff happen. And those connections are in our brain, the things that connect neurons, together. The corresponding thing in the computer model, that's the thing that there's a trillion of. When they talk about a trillion parameters,
right,
it's the trillion lines running between nodes or neurons. And that's where they said, back coming full circle, to compute power, you get enough compute power, you start to have enough ability to, literally simulating the brain, but you're getting the kind of thing of firing off a trillion different connections to go through.
On that, John, so I'm working on an article. We've been talking about the exponential rate of change, Ray Kurzweil. We've referenced that a couple times lately, and working on an article right now talking about just how incredible that is across the board, from Moore's law with semiconductors, and so the price per solar per photo. Can't think of the term right now, but genomics, all these things, right, where it's an exponential improvement in the number of things that you can produce, and then the cost goes down as well. In AI, is the number of parameters in the model, is that the appropriate metric to use? Like in semiconductors, we use the number of transistors on the same, it's not square inch, but the number of transistors on the same fixed physical area of silicon. So is it transistors that we should be, is it parameters that we should be measuring in AI? Is that how you measure AI? Is it gonna follow that same exponential curve where it's a trillion parameters and it's 10 trillion parameters and then it's 1 quintillion parameters? I mean, you see where I'm going with that?
Well, I think the parameter to transistor thing is a good, kind of comparison to draw. But probably it's true that on the side of transistors, people went and did things that made the computer smarter with a billion transistors than it was with a billion transistors. Like they went and did stuff on the side of what can you do with that. And so there's similar things that happen with parameters in language models and all the quantizing, and they're doing things to go and wow, now I fit it into only 32 billion, but it even performed as well as that one, which had 100 billion. So there's different things that go on. But overall, I would say the analogy is a good one.
So then I think, maybe somebody has posited this already, but I think the name is up for grabs, John. So I think if you could come and say affirmatively that the number of parameters is going to double every 2 years or 6 months, whatever the deal is, it could be a de Oliveira's law. And in 50 years, students at MIT will be like, well, according to de Oliveira's law, the LLMs next year will have 6.3 quintillion parameters.
I was looking up while you were asking about because I was like, who said this? And apparently, Professor Albert Bartlett famously stated, the greatest shortcoming of the human race is our inability to understand the exponential function.
Right.
So we don't get it. It doesn't matter that Ray Kurzweil says it and we think he's smart and we believe him and we agree with what he's saying. We can't internalize the notion of living on the curve. We constantly follow the tangent instead of the curve. So here's a curve, right? You're going along and I don't know, is this going up and to the right? You're like that. It curves up like that. And if you're on an exponential growth, then you're like, that's what's going to happen. But when you're here on the curve, you can't see, when you got here like this, you can't see that you're going to land like, up there. You see it like you are going to go in a straight line off from where you are, a tangent off that curve.
Yeah. And so I'm going to give you a sneak preview of one of the charts I'm using in the article, but this is GDP, global GDP since year one over here. And then today. And I mean, if you're sitting here at the year, even 1920, right? World GDP at that point is 5 trillion. You can't fast forward, 100 years and see GDP at 200 trillion or whatever it is up here. I mean, there's no way humanly possible 130 trillion in 2021, right?
To see what you see,
right?
You need to go zoom in that graph,
right,
to just the piece within 10 years either side of you. Collapse it in around the 1960s, around there. This is what people see.
Yeah.
So you to fathom that what's actually happening is that you're running straight toward a brick wall.
Right. Like this right here from 1920 to 1960 is nice growth, but it's not that exciting.
But it's on the same curve.
Right.
It's on the same function for that other thing.
And then you're like, oh, zoom out. Whoa. we just 10 bagged right there, or 100 bagged, 10 bagged, I think.
Right.
So
no matter how we say it, we don't get it. We don't feel it. And so, you can do it on a graph, but then people would have to have a lot of faith to look at the graph and go, okay, that's what it, what do you mean? It's like you stop and you go, what do you mean? What do you mean the GDP is going to be 10 years from now, 100 times what it is?
Yeah.
What do you, how it doesn't compute. What would that look like?
Yeah. Yeah. And the point of the article is that we know that those things are true, even though we can't see them in our day to day. And so that's why we have to keep reminding ourselves of that, keep betting on these revolutions, keep betting on the exponential rate of change, because we do know in the long run, over the next 50, 60, 80 years, that it's going to work. It always has. And despite all through war and peace, I mean, that was what Kurzweil's point was a couple of weeks ago. through feast and famine, it's up into the
I
right.
remember when I don't know if this relate. I think sort of just in a way of thinking about things. I remember that when I was about to get out of college, that I thought of life being like everything up until then was a lot of, activity and turmoil and important stuff. It was important because I was there, and that the stuff people did when you get out of college then you live life, which is like you flatline, like there's nothing interesting that happens at that point. And like I didn't have a picture for what it's like to be in that other kind of piece of life. So it's even worse than just look backwards and see that as what it looks like going forwards. But having I don't know, it's like you can't sense it. And now we have enough evidence that this kind of thing is going to happen. The stuff that's happened with computers and AI over the last even just couple of years is so astronomically advanced compared to where we were that it's evidence that like radical things are coming.
Yeah.
And we ought to really believe it at this point.
Yeah.
I don't know. I don't even know what does it mean, to like one thing that I see coming that I think, and this is like a Musk thing, that I see coming that makes me go, okay, we're in the future is, I was watching some video about how Elon Musk and SpaceX are like making a deal with like the Air Force, and they're looking at launching multiple rockets per day, every day, and setting up space stations the way we today have airports, but what do you call them? Air bases.
Okay.
And
so like instead of Air Force bases, we would have Space Force bases?
Or it's like they compared it to Navy bases. You take our biggest naval bases, and they're, here's our top 20 around the world or whatever. Like have 20 rocket bases and have those rockets going off every day. And they've already predicted that the cost for like transporting stuff is cheaper than sticking it in one of those C3s, or is that the latest, the C3, or is it a C1? But the giant transport planes that you can shove a tank into the nose of.
Oh, right.
Yeah. You'll be able to carry, I don't know about tanks, but you'll be able to carry more in that rocket than and for cheaper.
Wow. See, that's what's in space is the same way, right? Like the cost, you can go pull up charts on it, the cost per kilogram, how that's came down since 60 years ago. It used to be millions and tens of millions of dollars, and then now it's about $1,500 on $2,000 on a Falcon 9, and then with Starship it's going to go down to like 100 maybe. And Elon thinks it could go down to $10 per kilogram. Once it's at scale and doing like you're saying.
So there you go, that kind of stuff. You look at that and you go like, okay, am I going to look outside and see like multiple rockets flying back and forth on like every day the way we today see planes? That's insane.
Yeah, it seems ludicrous.
Yeah.
No, it's exciting. What else? I mean, one of Elon, we talk a lot about Elon and Tesla and AI, but FSD 12 is rolling out. That's full self-driving.
Yeah, tell me. I thought I read something, and I did. Like, how close are we? I mean, there was FSD 12 beta,
right?
People were trying it out, and it was like, and I saw the one where Elon went like door to door with it.
Yeah,
barely having to touch his steering wheel, or maybe he did one thing the whole ride. So what's happening there?
So I think they're on like 12.2.3 of the software or something like that, and they've done it in beta and rolled it out slowly to more and more consumers, and they're tweaking it, fixing bugs as they're doing this. But by most accounts, it's a really big leap forward from where full self-driving was with the last iteration. And in fact, Cody just got his over-the-air update over the weekend, I know, and he was uploading it or downloading it to his car rather.
Oh, we didn't get it yet. Yeah.
And he's going to test it out. I think he's pretty excited about it. But like Michael Dell came out and said it was, as good as a human could drive. And there's been a lot of, not just like Tesla fanboys riding around, bragging about it, but, independent third parties, and the reviews have been good. I don't think it's full self-driving yet, like it's named, but I think it's a pretty big step forward. And for those that don't know, the reason this software is so much better than the last edition is because they switched from a human programmed rules-based system where you pulled up to a stoplight, the cameras on the car see the stoplight, and then it goes back to the database, says, okay, what do I do now? It says stop. Okay. And then it proceeds, whatever. Now it's learning based on an end-to-end neural network, they call it, and is able to make those decisions on the fly based on millions of videos that it's watched and been trained on from real life drivers of Teslas over the years, rather than having to resort to a rules-based approach that somebody sat there and programmed.
It parallels what's going on with Android robotics. The company we talked about and there's like 10 robotics companies that are actually serious. And like there's one called 1X, and it means like at normal speed at one times. So you don't have to speed up the video to show what are these guys doing. There's like what they're doing, but they're called 1X, and they talked about and showed like end to end. And it was like, they're the ones I think that had the camera is like going through a couple different rooms in this building. Okay. And it's following around, and there's like 3 or 4 robots in every room doing different stuff. They didn't walk, they kind of roll, but they are arms and legs and hands, and like they can bend down and do stuff. And one of them's off cleaning up children's toys in a room over there. One of them's sorting things out of a bin, but they're just all doing stuff. And this is the point. There's no code was written.
Right.
It's kind of like the most they ever had was maybe like you get with OpenAI, like a prompt in English saying, "Hey, go clean up those toys."
Right.
So that's very similar to what's going on with this FSD.
Totally. And now one of the things NVIDIA introduced at GCT last week was what they're calling Project Groot, I think. And we talked a little bit about that last week, I believe. But basically, it's a foundation model, they call it, for humanoid robotics. So you can go in and license it. So John, if we wanted to start a robot company, we want to build our own humanoid robot, we could do that and then license, from NVIDIA, the software to train the robot so that it can learn using neural networks and just watch humans and learn from humans, rather than you and I sitting there programming, okay, here's an apple. This is what an apple is. Apples are red. Pick up the apple if I ask you for it. None of that, right? And NVIDIA is going to be the platform, maybe. And I think Tesla's going to do the same thing.
Yeah, it's going to be everybody but Tesla will use NVIDIA.
Right. But I think Tesla might license. I think they might do something similar. But yeah.
To be like NVIDIA meaning them providing it to others?
Yeah, I do. I think if Tesla, I likened it to like Apple and Google providing the operating systems for the apps that we all use, right? Like those are the 2 operating systems, and then that empowers everything else. I think NVIDIA.
What's the evidence for Tesla doing that with anything?
I mean, Elon has talked about licensing FSD to other car manufacturers.
Okay.
And he thinks, like, people ask him about it on earnings calls, the analysts do, and they're like, has Ford or GM approached you about doing licensing yet? And he's like, no, but they should because.
Well, they approached them about. There's an example. They approached them about the power, right?
The charging network.
Was that
the charging network? Yeah,
the charging network. They approached him about that. So
right, and so he's doing those kind of deals, and so I do think as those kind of companies start to figure out how stinking hard AI is and what Tesla's done is, how far behind they are, I think they would be smart to go and Toyota, for example. Toyota's a great company. They're not a tech company. They're not AI guys. But if Elon has a self-driving software that he can license to Toyota and throw it, and all of a sudden every Toyota Corolla or Tundra is a self-driving car, then I think Toyota would do that in a heartbeat. And then
what's the big Chinese EV company?
BYD.
And there's talk of them doing something with Tesla. So
yeah, I think so. Yeah, I don't know as much about that, but yeah, I think that's right. BYD is Tesla's biggest competitor, and they're a real competitor. They make a good product. It's cheap. Much more serious competitor for Tesla than Ford or GM.
So Waymo is not using Tesla. They're their own thing.
Right.
They're the self, kind of the self-drivers of the Uber of self-driving.
Yeah, that's probably a good way to put it. And I think Waymo uses LiDAR on their vehicles. I'm not 100% sure on that, which is a laser-based radar. And Elon is completely against that. He insists that the car should be able to function using only cameras, because he thinks that his same philosophy he has towards robots, they should be able to do what humans can do. And the world is designed for humans. So why are we going to make robots that don't know how to interact with the world in the way that humans do?
I don't have a piston in my leg to lift a grand piano. So I think there's some difference. No, I get that. And I can see, like, he's been right. He's proven right on going with just video in the cars. You try to mix other stuff into it and it complicates it. And if you can get it done with video, that's great. I was more thinking from the, partnership standpoint. I'm surprised that Waymo is even having any success because, Tesla is way out in front in terms of their ability with self-driving, I thought.
Yeah. And I don't even really know what Waymo's got going on. I think they have some pilot projects running, maybe in San Francisco and Phoenix.
Yeah.
Cruise is the GM subsidiary that was doing self-driving in San Francisco, and I think they're basically shut down right now. But it's hard. I think the scale and the money required and the talent, we keep going back to that, to do this is bigger than maybe most people estimate. And as evidence of that, it's taken Tesla a hell of a lot longer to get to this point than Elon thought it would when he introduced, full self-driving, like in 2019 or 2020, whenever that was. And he said, we'll be there next year.
So yeah, he's not the best in terms of his time estimates,
right?
But most of the things that he predicts do come true. They just happen later then. And that's happened with, AI. I was just reminded of, Marvin Minsky and Simon and Newell and those guys who invented AI back in the 1950s, saying that, within one generation, we will have computers smarter than people. And, maybe it's been 2 generations, if you count like generation as being 30 years.
Yeah.
So they weren't that far off. Is
everyone pretty comfortable saying that AI is smarter than any single human at this point?
No,
I
don't, like, when you hear AGI, that's supposed to be smart, that a computer being smarter than like the average Joe. And what's interesting is that if you go to try to do any, like where you give it a test to take and all this kind of stuff, like GPT-4 is way smarter than almost every human on the planet. Like it can pass, is there any human who can pass the medical exam and the bar exam and do great on the SATs and there's nobody near it. There's like 3 people on the planet who cross in front of it. Like there's Dr. Alan Thompson, the Australian, who talks about this stuff and tracks it and everything. He shows this stuff on this. He used to work before he got into AI. He was working with gifted children, and he was really aware of all the very high IQ stuff. And it's like, so it's way smarter than humans from that standpoint.
Right.
But then it goes and doesn't remember anything.
Right.
Or know why it matters what it is that it's doing.
Or when you ask it to make a picture, it can't put English words on there that are spelled correctly.
Yeah.
Don't.
Well, I can't do the make a picture side of the thing. So
yeah, stick figures is about the limit.
But like this goes a good point, which is, you're talking about this stuff like self-driving taking longer than expected, and there's things like this, and we're like, it's more work than they thought. Well, what kind of work? Well, thinking work. Oh, well, isn't that the stuff that these things are supposed to be helping us with?
Yeah, good
point.
Like,
when do we see the crossover to where ways these computers being all smart and everything actually pays off in the form of us solving some of these problems.
I think we're starting to get there. And my evidence of this, I've now said that this will be the third time I think on this call, but it's the NVIDIA chip using LLMs to design better NVIDIA chips. And this Blackwell version was designed using computational lithography, which was powered by AI. And so I think I'm going to keep using that example as I think that's one of the first things we've seen where it's actually accelerated something, in the real world.
So now that's a good example because it's a thing that got done faster because of AI or whatever. But if all it does is get that thing faster, and if getting faster isn't enough, meaning like if GPT-5 has more parameters than GPT-4, I don't know that gets us to quote AGI. There's a lot of talk now, even folks who were arguing that that's all you need, scale is all you need, are backing off. I don't know what Ilya is saying because they won't let him talk. But if you look at like Sam Altman, last year he was saying like all we need is just keep building it up.
Right.
And since then he's come out and said, we probably need more than just that.
Yeah.
So something has to give on some other axis there to get additionally to just the speed up.
What, as creative as AI is, right, with the pictures, now video, which will come out sometime this year, I think Elon has said, and I hate to keep referencing Elon, but I'm going to do it because I think he's pretty smart and he has these.
You think he's smart?
Yeah. He's pretty smart. Yeah, I think he's pretty smart.
Yeah.
He was like, it needs to solve some like problem of physics, like when does the AI help us with like a unified theory of physics or something like that, these incredibly difficult problems that Einstein and other geniuses of humankind were unable to answer.
Right, that's what they're saying is like when you start contributing to science, then we're going to believe you're really smart. Now,
but why can't, like, I don't know, I'm struggling. Like it can make this incredibly beautiful art. Like there's creative stuff in there somehow, but it can't. And it's also like bad at math. Like, like it can't be bad at algebra and come up with a unified theory of physics. That's not going to happen, I think.
GPT is bad at math, but it was it a project? I'm looking up AI and Math Olympiad. So the big toughest kind of math competition in the world, the kind of the Olympics of math, they got this AI involved in like, hey, can you answer these questions? And I guess it was DeepMind that started to do some interesting like proofs that computers couldn't do before, and that this would correspond to real creative thinking. And so there's some stuff you go look into. Well, what did they do there? It's like a generative adversarial kind of thing. Once again, like what DeepMind did with Go, give it some things to think about, come up with an answer, go back and see if that was a good answer or not, blah, blah, blah. But it's way beyond what something like GPT can do. And OpenAI just looks at everything happening out there and goes, okay, can we incorporate that? They're not just the transformer factory. They're the like, we're going to do AGI. We'll incorporate whatever. So there's hints of it starting to happen.
Yeah, I agree. We got this comment here from one of the viewers, John. It says, I think there will be a surprise breakthrough that kills NVIDIA's GPU monopoly.
Maybe Grok is that? I don't know.
Yeah, and he solved this. I don't know who this is. Real George Hotz.
Yeah, George Hotz. Yeah, so know the guy who he's the guy who made or makes the kind of the biggest competitor to Tesla in terms of self-driving. I'm
gonna have to look him up. I don't know.
Yeah, he's a very kind of cool programmer. He's done stuff where you can go
I've
and
seen this guy.
sit
Yeah.
there, watch him live stream while he codes, kind of thing. He's a totally legit technical guy. And so what
do
did he
you,
say?
do you follow? He's doing something kind of with chips, maybe the GPU competitor.
I didn't know that he was getting. Well, let me think about that for a second. I think I did. So there's also I thought what I thought remembered happening was more at the microcode level. So like one level up from the chips, and I thought he was involved in that, which reminds me of this company called Modular, and they have they made a new programming language. TinyCorp. But yes, I did hear TinyCorp.
Okay.
So Mojo is a programming language that is like compatible with Python. Like you can write something like you're writing Python, and it understands that. Yet it can do AI 36,000 times faster than Python.
Wow.
And like they show a demonstration of like the different things that they introduce at different points and aspects of a piece of code that's doing a PyTorch machine learning type thing. And they're showing the speed up of the speed up of the speed up. It's the guy who created Flutter, because it's software that a language that kind of iPhones, all their apps are built on, kind of thing. He went and created this new thing, and I feel like the thing that happening with TinyCorp was somehow related, but I'd have to look it back up. But yeah, so but there's that, and then like we were saying, there's Grok. They made the language processing unit, which I did look up more about Grok and what they're doing. And think of it like this: if you're looking at you can find a video on this. But if you look at the Blackwell, and like the miniaturization in the chip is all these little processors with memory along the side, and at any given moment, one of those processors is doing something, and it's looking up something from its own little on-chip memory. Well, it is not predictable the amount of time it's going to go. It can go anywhere from 50 nanoseconds to 120 nanoseconds. It's like it's not a predictable amount of time. Because of that, everything's waiting until something happens, until the next thing can happen. You watch it go, and how it's just kind of slows the whole thing down. On the Grok side of things, because everything takes the exact same amount of time, it's like, that one can go as low as 30. This one on Grok, it's not the fastest. At its fastest, it's not as fast as Blackwell's fastest, but it's always 50. It's not 30 to 120 to 30 to 120. And as a result, since it's always 50, what that means is everything happens in lockstep. It flows through, and it's just everything's always running. It knows what to expect.
I did want to share here, John, just for some of the viewers that may not be familiar. Grok is GROQ, and this is a chip startup that's going to compete with NVIDIA, and it does inference, LPU inference engine, but it's not to be confused with GROK, which is the X.com Twitter LLM. So I just wanted to throw that up there for anybody interested in what John's talking about. It's GROQ. Grok.
And the Grok chip was made 3 or 4 years ago. That it's not like they are, we got all this money that NVIDIA has and we're going to move things fast and whatever. It's been sitting there. It was already like, it was like the quiet secret that no one knew what was going on. But
right.
And it's what do you call it? It's size per transistor kind of thing. What is NVIDIA at? 3 nanometers? Something ridiculously tiny, right?
Right. Yeah. So that's they're on the 3 nanometer node at TSMC right now.
So Grok is 4 times bigger, which is worse.
Right.
And yet it's still doing this amazing.
That was the most impressive thing I saw when I did a little research on them. Was I think they did it on 14 nanometer technology from Global Foundries, no less, which is like an old school. Global Foundries was actually AMD's in-house foundry division when it was an integrated device manufacturer at IDM, and they spun it off because they didn't want to be in the manufacturing business anymore. And so Global Foundries is typically not considered to be on the cutting edge of chip manufacturing at all. And yet somehow they made this incredible chip for Grok that works really well. If you believe the numbers.
Something else you may start hearing more about is analog. So there were analog chips back, 60 years ago or something, and digital won. But now the type of computing that's needed for what's happening with these large language models that are doing AI, it has a lot of like stochastic processing. So it's got stuff that's almost got randomness built into it, but it's very compute intensive to take a digital machine and have it sort of, it's almost like it's simulating analog with what it does. Analog is way less power to use it, and can do the kind of stuff, those kind of computations way faster, because it gets down to like using every electron.
Yeah,
it's because it's not predictable in what it does, but in some cases that's a feature, not a bug.
Yeah,
right. So the problem is that it's like, oh well, great, let's just use that then. Yeah, but every distinct machine using an analog thing and going and learning, it can't share it. It can't just copy it off somewhere. It's literally like changing it to itself, in a way that can't be easily shared around. So how do you make use of that is to be figured out still.
I think I've read that analog chip design is more of an art than a science. And I think there's a lot of experience involved with people that have been doing it for years. And so there's really two big analog chip designers. It's Texas Instruments and then ADI, Analog Devices. And they've been doing it for years. Texas Instruments is one of the first chip companies ever founded in the 40s. And so, but those guys have like ridiculously high gross margins. They're really entrenched in what they do. So there probably is, if I was going to have maybe like a hot take here, maybe like those are the ones that get disrupted before NVIDIA does, because I think NVIDIA is on the cutting edge. They're pushing the limits of physics. Texas Instruments, Analog Devices are probably, sitting pretty. They think they've got these great business that's going to be good forever. And, maybe AI enables some new startup that really comes in.
Yeah, maybe there's some way that, the NVIDIA made, like now they're making the stuff directly for AI. What were they making? They were making GPUs.
Yeah.
And it's graphics processing units. So they're like alongside your CPU in your gaming PC is this thing that NVIDIA made. Well, maybe analog becomes the alongside chip for AI, and there's certain aspects that can get fed off for it to handle.
Yeah, and totally. And I heard someone say once that the world is analog. The world's not digital, right?
You don't know that. That's the big debate. I mean,
okay, all right.
The simulation hypothesis is, are we just in a simulation? If it's so easy for us to go and create a world, and by the way, if you haven't watched it, you got to check out the Three Body Problem on Netflix that came out last week. It's unbelievable.
Okay,
sci-fi. But it's like, if we get so good at making doing what NVIDIA is doing with their foundation thing to go like make a world inside the computer that has
the omniverse,
then maybe that's what's happening to us.
Yeah. That's a theory. Elon loves to talk about that one as well. One of his favorite conspiracy. I don't know. Do you even call that a conspiracy theory? I mean, it's
I don't think it's
not a conspiracy theory.
Yeah, but it's a theory.
Yeah, it's a theory. But yeah, and there are other chip startups. There's a company called Cerebras that's doing an inference chip. It's got 4 trillion.
Aren't they the one that did they do the wafer?
Yeah, it's the full size wafer.
Okay,
yeah.
So a chip is when lithography or whatever that goes and like the lasers and all, when they go and make a chip, what they make is a big wafer like this.
Yeah, like 12 inches diameter.
Cut out of it is like all these little chips. And what they did was said, yeah, let's not cut it.
Right.
Like they take that whole thing and it's so awesome.
Yeah. And so you can understand why that would be a powerful chip when it's at 12 inches in diameter, whereas my CPU in my computer is half an inch or something squared.
Well, and why are these things powerful to be more chip? It's because the speed that we were just talking about, the speed like on the chip as being like, 30 nanoseconds or something to get. And what is that? It's the speed to get from stuff that's in memory to stuff that's in processor. We're back to the von Neumann architecture where memory and compute and CPU or processor are separated from each other. And it's all about the speed to go like this. That speed is what, 10 times faster than going out to memory as in on a separate chip somewhere.
Right.
Because then it's got to go out over a bus, get the thing, whatever. So more that can happen on the chip, the better.
Right. Totally. And I do think part of not the Blackwell chip, but the larger like server rack thing that NVIDIA introduced last week has a lot of memory built into the board that's much closer to the processing along those lines of what you're talking about.
I actually, I looked at their video where they show the little processor, and then they show the chip and the die thing, and then two of them next to each other, and then one here, and they kind of build it up and out into all of them. I was like, this is so awesome.
Yeah.
They know it, but it's like it's like tech porn. It's like this beautiful kind of room full of compute, and you're just like, oh, I want that.
Yeah. What can we do with all that compute?
Awesome. If that thing, if that one chip is $40,000, and then they show it the two chips and the one and the boom, and it backs off and off, and it's like, then here's a rack of them. That rack of them there, you're already up to $4 million.
Yeah.
And then you go this whole section over here. That was a multi-billion-dollar room.
Right. Yeah. Just the data center. Yeah. The cost of the data center is going to go up tremendously if we'll fill them all up with these $40,000 AI chips from NVIDIA. But no, I mean, and I think the bigger point here is what everybody keeps questioning is that the demand is so high. The margins are so high. NVIDIA is just printing cash right now, selling these chips that, competition is bound to come along. And obviously it is starting to come along, but it hasn't made a dent in NVIDIA's sales or margins at all. And so I think it's going to be longer than everybody thought before there's a real competitor. Even AMD and Intel haven't made anything that's even come close.
It's old IBM saying, embrace and extend, which is taking the strategy where I'm not going to take on NVIDIA. I'm going to go and say their stuff's fabulous and it works even better with my stuff alongside of it. And then that's embrace, and then extend, kind of start to push NVIDIA out of the way if you get something, good enough.
Yeah.
It'll take a
John, we're coming up on an hour here. Do you have final thoughts?
The thought I have is that it flew.
It did.
Yeah.
This was fun. I think for not having much news this last week, we ended up talking about a lot of news that happened last week.
Yeah. You catch up on the different, things that had been happening, and it's just like we've been getting barraged by stuff. And I gotta say, we had a bit of a slowdown there one week. Let's see what happens. Next week has literally been week after week, just crazy things on top of each other.
Yeah. So everybody tune in next week. John D'Oliveira, AI industry expert, Cody Willard is usually here, hedge fund manager, tradingwithcody.com. Check us out there. We do real-time trade alerts. We own NVIDIA. We've been in NVIDIA since 2016. It was $8 a share back then. We're here every week, and we talk about the AI revolution and where it's going. So we'll see you all next week.
Thanks a lot, Bryce. We'll see you.
Thanks, John. Appreciate it, as always.